we have learned the so-called Snell's equation of wave normal. This equation normal surface, Snell's equation with normal as x squared over n squared minus nx squared plus sy squared over n squared and ny squared plus sc squared over n squared minus nc squared 1 over n squared. Okay. We are given the parameters about the crystal. Nx squared is epsilon x over epsilon 0. Ny squared is defined as epsilon y over epsilon 0. And nc squared is defined as epsilon c over epsilon 0. And then you consider a propagation direction S as three components Sx, Sy, and Sd. Okay, and S is a unit vector. S is a unit vector. So this is the sum of the three square terms. Okay? And then you can use this factor. Okay? You can use this factor that we can write the result as, because we can replace this one by the sum of these three terms. So we have 1 over n squared sx squared plus sy squared plus sc squared. Okay? So we can rewrite the equation as this. So this equation tells us that here is 0. So the difference between these two terms is this one. Okay? And similarly for this and this. So finally, when we multiply n squared to the result, we get this. So if you want to use the Snell's equation of wave normal to solve for the refractive index in this n, you may start from this result because according to this result, if you multiply this expression by n squared minus nx squared, n squared minus ny squared, n squared minus nz squared. You multiply this factor to this equation, then you obtain a fourth power equation written as this: a to the n to the power 4 quotient and plus b times n squared plus c equal to 0. Okay, we have a quotient equation 四次方程式，我们有一个4次方程式我把这个东西乘到它，就把它写成了一个4次方程式那这个4次方程式呢，你可以用来解出2个 n。So you get 2 square of refracting this, which are given by this, okay, and then you take the square root to find the corresponding refracting distance. So once you are given the propagation direction and the three reference refractive indices nx, ny, and nz, then you get 2 possible refractive indices. This means that corresponding to one propagation direction, you have 2 different refractive indices. However, we know that the k vector is related to the refractive indices and the propagation unit vector by this formula. This means that for one frequency and the one propagation direction, we have 2 possible k vectors. The first one is omega over c times n1 times s. The second one is omega over c times n2 times s. Okay? So this means that corresponding to one propagation direction and one frequency, suppose you want to find at this fixed frequency omega all possible propagation direction, what is the surface related k to omega? Okay. We want to know the function omega of k. Then you find that there are in fact 2 surfaces there are in fact 2 possible surfaces. We get the double shell structure.我们实际上会得到的是，假设你给定一个，你固定一个频率，固定一个频率的时候呢，你在 isotropic 介词里面，你把所有可能传播方向的 k 画出来，你得到是一个球壳。啊，但是呢，如果你在这个 anisotropic 介词里面呢，你固定一个频率，你考虑所有可能的传播方向的时候，现在的问题是，对一个传播方向你会有2个折射率，因为这边会解出2个折射率。那解出2个折射率呢？假设你想把所有方向的 k 都画出来，啊，就对那一个频率所有方向的 k 都画出来，你会得到一个双层的结构，啊，这个双层的曲面，啊，这个双层的曲面，啊 ，so you get a very strange surface. The surface is described by a quartic equation. This quartic equation 4次的方程式。4次的方程式。So, if you want to know this coefficient A, B, C, you just multiply this factor to this equation. Then you can find the 3 coefficients A, B, and C. There is another way to find the equation omega of K1, K2. The method is this. Suppose, recall that we derived the normal surface by this method, omega squared mu epsilon x, okay, minus ky squared minus kz squared, okay, omega squared minus kz squared, kx squared. Oh, sorry. Mu epsilon y minus kc squared, kx squared. Okay. Omega squared mu epsilon z minus kx squared minus ky squared. And here we have kx, ky, kx, ky, kx, kz, kx, kz, ky, kz, ky, kz equal to 0. Okay. We derived the Fresnel's equation of wave normal from the 0 value condition of this determinant. Okay. And then we remember that omega squared mu epsilon x is equal to omega squared mu epsilon 0 times epsilon x over epsilon 0. Okay. And remember that we are considering the non-magnetic material. So mu is just equal to mu 0. And mu 0 times epsilon 0 is 1 over c squared. So we get omega over c squared. And the ratio is nx squared, okay? Nx squared. So this equation, it can be written as, this can be rewritten as omega over c squared nx squared, okay? And this part can be rewritten as omega over c squared ny squared. And this becomes omega over c squared nz squared, okay? So this zero value condition is equivalent to the quadratic equation. So this gives us the so-called normal surface equation. Now I want to know what is the intersection of the normal surface with the coordinate plane. 就是说这个双层结构啊，它跟坐标平面的交集会长成什么样子？会长成什么样子？我们如果是球面的时候，球面跟坐标平面的交集，因为坐标平面穿过球心嘛，它就是一个圆嘛。可是现在这个奇形怪状的曲面，它现在跟3个坐标面的交集会长成什么样子？这个可以帮助我们去了解一些细节。所以我们现在来考虑这个曲面，这个奇怪的4次方的曲面，跟坐标面的交集会是什么曲线？So now we consider what is the intersection of this very strange surface, the intersection of this surface with the coordinate plane. Okay, we assume hereafter we assume that nx is smaller than ny and ny is smaller than nc. Okay, we assume this order of these 3 reference reflecting indices. So if we want to know the intersection of this surface with the kx-kz plane, now I consider what is the intersection of this surface with the kx-kz plane. Kx-kz plane. Kx-kz plane means that ky is equal to 0. So I substitute the ky equal to 0 into this 0 value condition, okay, to see what is the result. So when I set ky to be equal to 0, I get this omega over c squared nx squared minus kc squared. Okay, and this one omega over c squared ny squared minus k squared omega over c squared nz squared minus kx squared. 0, 0, kx, kz, kx, kz, 0, 0. Okay. Here I write the summation of kx squared and kz squared as k squared because now ky is equal to 0. Originally we have k squared equal to the sum of kx squared plus ky squared plus kz squared. But now ky is equal to 0, so the summation of kx squared and kz squared becomes k squared. Okay? So what is the result of this equation? Okay. So we have this omega over c squared nx squared minus kx squared omega over c squared ny squared minus k squared omega over c squared nz squared minus kx squared. Okay. Plus 0 and 0 and minus omega over c squared ny squared minus k squared times kx squared kz squared, okay, equal to 0. So now I have this omega over c squared ny squared minus k squared times here this is kc, okay. Omega over c fourth power nx squared nz squared, okay, minus omega over c squared nz squared kz squared plus nx squared kx squared. Okay. And finally we have the product of the kx squared and the kz squared minus this kx squared kz squared. Okay. So we have this. So what is this result? If I divide this result by minus ny squared, okay, because now we have 0, we can divide 0 by anything non-zero value, any non-zero value without altering the result. Okay. I divide this part by minus ny squared, I get k squared over ny squared minus omega over c squared. Okay? And I divide this part by minus omega over c squared nx squared nc squared. Okay? So I get kx squared over nz squared plus kz squared over nx squared minus omega over c squared equal to 0. Okay. So what does this result mean? This part describes a circle. And this part describes an ellipse. Okay. So if you plot them together, here I have kx, kz left. Ky is along the direction perpendicular to the black hole. Okay. And now this ellipse here we have this semi-major axis equal to nz omega over c, and this semi-minor axis equal to nx omega over c. Okay, and then since ny is between nx and nz, ny is larger than nx and smaller than nz. This means that the circle has the radius ny times omega over c, which means here this is ny omega over c. OK， 好，这画的很烂，但是你把它想成就是一个圆。This is a circle. The circle has the radius. The radius is equal to ny omega over c. Here, this part we have ny omega over c. Here we also have the radius ny omega over c. Okay? Because sorry, 没错，好。Okay. ny is larger than nx, and ny is smaller than nz. Okay, here, 把这个nz omega over c. Okay, here nx omega over c. 好，所以我们看到就是说，我们有一个椭圆跟一个圆嘛。那圆的半径比椭圆的半短轴长，比椭圆的半长轴短，啊，所以就会有这个交叉。 The radius of this circle is smaller than the major, semi-major axis, smaller than the semi-major axis of the ellipse, and larger than the semi-major axis of the ellipse. 就比这两个轴一个长一个短，所以就会有交叉。 minor axis， 然后呢，我现在呢，如果把它连起来 ，now you see that there are 4 very special points. At this point, the 2 refracting index becomes 1。就是我们刚刚说，给一个方向会解出2个折射率嘛。就是我们现在，比如说我现在suppose I choose this direction to be the propagation direction. I get the 2 possible refracting indices. The smaller one gives us the point corresponding to this circle. The larger one gives us the point corresponding to the point at the ellipse. Okay? However, if I change the direction, then at this very specific direction, I get only 1 refracting index. 就因为这两个交叉了，变成同一点，变成同一点。So this very special direction is called optic axis. Okay, this is the optic axis number 1, and this is the optic axis number 2. Okay, so if 3 refractive indices are all different, we have 2 possible optic axes. 我们会有2个光轴，光轴。什么是光轴呢？ Optic axis is the direction that the 2 possible refractive indices becomes 1 refractive index. 就只有一个折射率，在光轴上只有一个折射率。Although at this special direction we have only 1 refractive index. However, if you want to find the polarization vector of the D vector, you still get 2 different D vector. 就虽然是得到一个折射率，但它的2个 D vector 还是不一样，还是不一样啊。好，那这个是光轴比较特别的地方啊。So, if I want to know the intersection of this double shell structure with the other 2 coordinate plane, what is the result? Okay. 好，现在假设我要看的不是 KX、KZ plane， 而是其他的 plane 会怎么样？我们会预期还会得到一模一样的方程式，只是把坐标换掉，对不对？把坐标换掉，比如说 KX、KZ 的时候，这边是 XZ、ZX。如果是 KX、KY 的时候是 XY、YX， 如果是KY、KZ 的时候是 YZ、ZY， 好，就换掉了。但是画出来会是什么图呢 ？So you know that if we consider other coordinate plane, we still get the same form equations. However, what is the curves look like? What does the curve look like? Now we consider KX, KY plane. We still have the result that NX smaller than NY smaller than NZ. So you know that now you have one circle equal to one circle described by this, and the ellipse is described by this equation. So if you plot the curves, now you know that since NC is the largest one, so now you have a large circle and a small ellipse. Okay? So this means that Kx, Ky, now you have an ellipse of this form. Okay. Here we have ny omega over c and this nx omega over c. Okay? And now you have a large circle. Now you have a large circle. The circle have the radius nc omega over c. nc omega over c. Okay? So now at the kx, ky plane, you have no optic axis. Okay? Optic axis means the intersection of the circle and the ellipse. But now there is no intersection anymore. Okay, between these two curves. Okay. 好，然后再来就是kx kz 有了 ky kz 有了啊，这是 kx kz 啊，这个是 ky kz kx ky kx ky， 再来就是 ky kz 本啊 ky kz 本。那如果我们看 ky kz 本会是 Now we consider ky kz plan. ky kz plan. For ky kz plan, we have a circle of radius nx omega over c. Y c c y. Okay. So now the smallest one is the circle. Okay. 好，所以现在呢，如果是 ky kz plan 的话是这样。ky kz nx omega over c nx omega over c 这边是ny omega over c nc omega over c 好，所以你会看到说在 kx kz plan 你有一个会跟圆交叉的椭圆，这两个会有交叉，交叉的这两条线是所谓的光轴。光轴啊，我们会有两个光轴。两个光轴，这是 kx kz plan。那如果你看的是 kx ky plan 的时候，你还是假设 n 的顺序是这样的时候，你会看到是圆最大，椭圆比较小，所以是圆包住椭圆，没有光轴。那如果你看的是 ky kz plan 是椭圆比较大，圆比较小，是椭圆包住的圆，也没有光轴。所以光轴现在在哪里？光轴在 kx kz plan。So the two optic axes are in the kx kz plan. This is because now we fix the order as nx lower than ny is smaller than nz. If we change the order, the optic axis will appear at different coordinate plane. 就我们把这个顺序改掉的话，光轴就会在不同的 plane。OK， 好，所以你不是去记 x y z， 你是要去记大小。啊，就是这个。总之呢，你可以这样想啊，就你排一个顺序之后，啊，你排一个顺序啊，排一个顺序之后，啊，这时候呢，夹在中间的那个是圆，然后两边的这个是椭圆的半长轴跟半短轴。然后你这样就知道那个光轴在哪个平面上，光轴在哪个平面上。那当我们考虑的光传播方向是沿着光轴方向的时候，它只有一个折射率，就是它的 k 只有一个长度啊。那如果你是考虑到其他方向的话，它就会有两个折射率，就会有两个长度啊，两个长度啊。So if you plot normal surface, you get the result like this.好，我现在画的这三个图，其实课本是有的啊。课本在第几节呢？在这个91页啊。91页的 Figure 4.8，所以你去看91页 Figure 4.8就有这三个图，好，这三个图，好。So the so-called normal surface kx, kc, ky， 如果是这样子，我看一下，这边kt， 这边 kc， 这边 kx。这边这个截距是 nc omega over c， 这个截距是 nx omega over c， 然后这个是 ny omega over c， 是 ny omega over c。然后在这个另外一个平面上 ，xy 平面的时候，nx omega over c， 然后这个是nz omega over c。 啊，你们自己体会一下啊，自己体会一下。那同学如果那个想要更清楚知道这个奇怪的曲面长成什么形状，可以简单写一个程式，把它跑出来。那这个程式其实不难写，我早上这个上课前我就写了一个。好，那实际上就是你要先知道那3个系数 A、B、C。好，就是你给了 nx、ny、nz 之后，你给定一个传播方向之后，你可以算出系数 A、B、C， 然后你就可以解出 N1、N2。你解出 N1、N2 之后，你再把它那个乘上欧贝伽和 C 乘上那个单位向量，你就得到了 K， 然后你就可以把它画出来。好，说的很简单了，但是实际上就是说，实际上你就是基本上你要把一个东西这种东西参数化，一个很简单的方式是引入那个极坐标啊。极坐标的话，你就是给 θ 跟 phi， 然后 θ、phi 知道之后，你就可以定出 s(x)、x(y)、s(z)。你解出 s(x)、x(y)、s(d) 之后，然后你就可以去定系数 a、b、c。a、b、c 定出来之后，你就解出 n。解出 n 之后，你后续就可以把东西都写下来。好，然后你画图的时候呢，我是建议只要画一半就好，就是它实际上有这个其实只有1/8。好，实际上是整个是一个双层曲面，但这个只画了1/8。你画1/8或者画这个1/2，就上半球面，这个都比较容易看啊。如果全部画出来就会不太容易看。好，那实际上你可以自己玩一下。好 ，so you can write some say MATLAB code to see what is the shape of this normal surface. 好，那我们一旦知道这个形状之后，知道它是每一个平面上是一个圆一个椭圆，但是我要强调的是说，你不能把它看成说是一个椭球加一个球，至少你觉得它不是这样。好 ，so although this double shell structure have the 3 possible intersection with the coordinate plane, behave like one circle and one ellipse. However, you cannot just think this strange surface as the collection of an ellipsoid with a sphere. It is not that simple. Okay, it is a more complicated surface. However, in some special case, say if nx is equal to ny or ny equal to nz, then we have something called unit actual crystal, 单轴晶体. For those simple cases, then we can say that the normal surface becomes one sphere together with one ellipsoid. 就是一个椭球再加一个球面，在那个情况下会是这样，但是在其他的情况下，它是一个比较复杂的曲面。好，那但是它在3个坐标面上的交集是简单的圆加椭圆。好，就这样。好，我们这边先下课10分钟。